Hey guys, I'm going to teach you all about rotations on the coordinate plane. By the end of this lesson, you'll be able to rotate the pre-image of a figure around a center of rotation to create a congruent image that's just turned 90, 180, 270, or 360 degrees. Go ahead and get out your binder, turn to the math section, get ready to take some notes. So just like translations are slides, reflections are flips, rotations are a type of rigid transformation that is a turn. And the important thing that you know about turns are that they have to turn around a fixed point. We call that point the center of rotation. Here you can see three wheels. The center of rotation is the point in the middle that they all rotate around. So in the tire, it's that middle part that the tire rotates around. On the spinner, it's the spin. And on this wheel here, it'd be where that spoke would go in. Those are the center of rotation. It's just a fixed point that everything else spins around. Since we're looking at rotations on the coordinate plane, we're going to use the origin as the center of rotation. And the origin is the 0, 0 point on a graph. We'll also be rotating in increments of 90 degrees. When I think about rotations, I always think about skating. So if I'm on a skateboard and I make one 90-degree rotation, I have turned one time. You probably have heard of a 180. That's if you turn all the way around. If you turn one more time, you've gone 90 more. So that's 270. And all the way around is a 360. So I always think about 90 degrees as one turn, 180 degrees as two turns, 270 as three turns, and 360 as four turns. When you turn four times, you're back to your original orientation. So the two words you need to know for rotations are clockwise and counterclockwise. The direction of the rotation matters. So obviously clockwise is the way a clock goes. When you think about a clock, it ticks this way. When you think about counterclockwise, it's just the opposite. So it would be a turn this way. And on the coordinate plane, if we're looking at a clockwise rotation, we can consider each quadrant as another 90-degree rotation. So we'll start with quadrant 1 as our 0, or our starting point. If we turn one time or go to the next quadrant, we'd be in quadrant 4, and that would be one 90-degree rotation. If we rotate one more time, we would be completely opposite from our starting point. It means we've done a 180. If we turn one more time, we're at 270 degrees, and if we turn one more time all the way around, we'd be at a 360, back to our starting point. So we're going to look at these three examples of rotation, and we're going to find the number of degrees in each rotation, both clockwise and counterclockwise. I'll do number 1 first. The first thing I notice about number 1 is that I have an original shape. This is the pre-image of A. I know that a transformation has occurred because I see another congruent shape with an A prime. Since the figure has turned on its side one way into another quadrant, there has been one rotation. Going clockwise, I know it turned on its side one time, so there's one 90-degree rotation. Now, the problem didn't tell me if this was a clockwise or counterclockwise rotation, so I'm going to consider it both ways. Going counterclockwise, it would be 90, 180, 270. One way to check if you're doing these right is that you know that the sum of the clockwise and counterclockwise rotation should be 360 in total. So take a second and try 2 and 3 on your own, and then press play when you're ready to check. All right, on number 2, the pre-image is here at regular B. It goes 1, 2, 3 turns to put it at 270 degrees as a clockwise rotation. And if it went the other way, that would be counterclockwise into another quadrant. That would represent a 90-degree counterclockwise rotation. Number 3 is 180 either way you look at it. Whether you go 2 times this way or 2 times this way, it started in the third quadrant and made its way back to the first one. That's a 180-degree rotation. Now you should try number 4, 5, and 6 all by yourself, and then press play whenever you're ready to check. All right, here are your answers for 4, 5, and 6. If you got these right, you can skip ahead in the video. Otherwise, pay attention. I'm going to go through each one. Number 4, I have a pre-image in quadrant 1. I know that it's turned on its side to get to the image of D prime. Since it's turned one time around the origin, I know that that would be a 90-degree counterclockwise rotation. If I think about it the other way and go 1, 2, 3 times, that represents a 270-degree rotation. Number 5 is a rotation. It's not a reflection. A lot of people might look at this and think that the y-axis was the line of reflection. It's not, because if it was, it would look something like this and be on the other side of the y line. Since it's moved and it's in the first quadrant, and this is in the third quadrant, I know that there's been a rotation. Since it turned 2 times, there's been a 180-degree rotation, clockwise and counterclockwise. And then finally, number 6, the pre-image turned one time clockwise to create a 90-degree rotation, or 1, 2, 3 times counterclockwise, which is 270 degrees. All right, so now we're going to actually rotate a figure. I will say this is difficult to do digitally, so if you have this on paper, I would use some sort of transparent material to cover the triangle, trace the triangle, and then actually rotate that figure about the origin. Trace your points and plot them in the tables below. If you're just watching the digital version of this, just pay attention. I'm going to do it for you, and then you will be able to see the pattern emerge. So if you can do that, pause the video now and press play whenever you're ready to check. All right, so this is what it looks like whenever you rotate this triangle around the origin. Each clockwise turn represents a 90-degree rotation. Pay attention to the fact that the A's are all still on the inside. The orientation of the vertices stayed the same. Now look at the pattern that emerged. Just starting with the 90-degree clockwise rotation, for point A, it was at 2, 1. Then it changed to 1 and -2. For each one of these points, the y and the x switched positions, and the x became negative, or the opposite. So to represent that algebraically, we can switch the position of the x and the y and represent that the x is opposite signs by putting a negative in front of it. 180-degree clockwise rotation, something else happens. The x and the y stay the same place. However, both of them are the opposite sign. So where it started at 2 and 1, it's still at a 2, 1, except since it's in the third quadrant, it's negative, negative. A 270-degree clockwise rotation is similar to the 90-degree. The y and the x switch position, except this time, the y is the opposite sign. So noticing that pattern can be helpful, especially if you're not given the coordinate plane or the figures drawn on it. For example, on 8, 9, and 10, you know that a transformation has occurred because x turns into x prime. It's an x with an eyelash, so a transformation has occurred. In this case, I know that it is a rotation because it tells me, and I want to use what I just learned from these tables to figure out how many degrees did that point rotate. I know that the starting point is at x, comma, y. So 9 is the x and y is the 8. Now what changed? I know they switched places, so instead of it being x, y, it now is y, comma, x. I also know that the x is the opposite sign. It changed from a 9 to a -9. Since the pattern is y negative x, I'm going to look at the algebraic representation of each one of these rotations and see which one that matches with. I can see that matches with the 90-degree clockwise rotation, or since 90 degrees clockwise is the same as 270 degrees counterclockwise, I'll go ahead and write that too. So try 9 and 10 by yourself, and then press play whenever you're ready to check. All right, so here's what you should have put for 9 and 10. I don't expect you to memorize the rules for these. I don't have them memorized, but I did want you to notice the pattern, and I want you to be able to problem solve this. So if you could always sketch a coordinate plane and then just note how many quadrants the point was rotated. It is important for you to remember the 90-degree rotation represents each quadrant in the coordinate plane. It's easier to visualize that than to try to memorize those rules. Like we noticed in the example above, rotations changed the orientation of the figure. It was moved around, but the vertices were preserved. They were still in the same order as we rotated the figure. If I could have you summarize this lesson and take away anything, I want you to remember that rotations happen in 90-degree increments. Each quadrant on the coordinate plane represents 90 degrees if it's rotating about the origin. Clockwise is this way, counterclockwise is this way. All right, guys, that's it. If you made it to the end of this video, please put in the comments, what could the rotation have been to get from this pre-image to this image? Today we learned all about rotations on the coordinate plane, so now you should be able to rotate the pre-image of a figure around a center of rotation to create congruent images. Those are turned 90 degrees, 180 degrees, 270 degrees, or 360 degrees. Now you should go back to the calendar and complete any other assignments you have left for the day. If you have any questions, bye!